Okay, today we're going to talk about segment and angle addition postulate. And before we talk about what that postulate means, let's talk about the definition of length and distance. Remember, the length is how long something is, and we use length to find distance. One thing that we're going to use today are segments. And remember, the definition of a segment is a piece of a line that starts and stops. So the first way that we're going to find the length of a segment is on a number line. And you can simply count that. You can also use the formula here and say A minus B. A being the starting endpoint, B being the ending endpoint. But you also have to do what's called the absolute value. Remember, absolute value is the distance from 0 to that number on the number line. And think of distance as always being positive, like absolute value. If you had a step counter on your watch and you walk backwards, your step counter does not subtract steps. It always adds. It's always a positive value. So let's just do some examples here. Example 1 says, find the distance between -2 and 6 on a number line. You can draw a number line, or you can just simply plug it into that formula. -2 being the A, 6 being the B, and then we'll do the absolute value. So -2 minus 6 is -8, but the absolute value, the distance from -8 to 0 in a number line, is 8. And so that would be the distance between those two values on a number line. Okay, we actually have a number line to look at here, so let's calculate the distance here, and we can simply just count this one. That way you can see two different ways to do this. So if you notice, P is on a halfway mark, so I'm going to count a whole jump to the next halfway mark, and then I can see that it's a half. So the distance from P to Q is 1.5. Okay, now let's look Q to R. Q starts at a whole number, so we can count 1, 2, 3, 4, but R is halfway, and so there's a half. So 1, 2, 3, 4, and a half. Then we can look and go from P to R. So P is on a halfway mark, so we're going to count those halves. 1, 2, 3, 4, 5, 6. Okay, let's look at something here. Do you see how if we were to start at the P and end at the R, when we did from P to Q at the beginning in blue and then Q to R in red, it equaled the same thing as the green. So we can look here and say, okay, well, is 1.5 plus 4.5 6? Yes. We can see the two halves make a whole. 4 plus 1 is 5, plus that whole makes 6. And so we can see here that if we take those two parts and put them together, it equals the whole segment. And so we can say PQ plus QR, and put that line segment above it, equals the whole length of PR, which is now what we call our segment addition postulate. Our two parts together, part plus part equals whole. And this is something I really want you to highlight right here and there in purple. Part plus part equals whole. And just to give you a visual, here's one part, Q to R is the second part, P to R is the whole thing. Okay, so let's look at a few examples here. We can see that R to S is one part, S to T is the other part, and R to T is the whole thing. Label your picture so you can see who the parts are and who the whole segment is. So we can set up an equation, part plus part equals whole. That's always going to work for segment addition postulate. We can substitute in our parts. So 2x plus 7 plus 28 equals 4x. So let's combine our like terms. 7 and 28 get combined, so we can say 2x plus 35 equals 4x. Move your 2x over and subtract, so 35 equals 2x. Divide by 2, x equals 17.5. Now, look at the question. Always, always, always look at the question. It doesn't say find x. It says find what RT equals. So we're going to go over here to the side and say, well, RT in the picture, the whole thing was 4x. Well, we now know what x is, so let's substitute it in and say 4 times 17.5, and that gives us 70. So our final statement can be that RT, what they asked us to find, has a length of 70. Okay, now let's take that up a notch. We have to create our picture this time, and I can also kind of glance through here and see some exponents that we're going to work with. So it says point M is between L and N on line segment LN. So let's draw that. And between does not mean right in the middle, it just means somewhere between. So that's point M, and we have LN. Use the given information to write an equation in terms of x, solve that equation, check for extraneous solutions, and then find the lengths of those two segments. So we've got several parts here, so write small. Let's label in our picture what was given. LM is x squared minus 20x. MN was given as x squared minus 7x. And the whole thing, L to N, is 45. So we can see here that we have our two parts and we have our whole length. Part plus part equals whole. So let's set up that equation. X squared minus 20x, there's part 1, plus x squared minus 7x, part 2, equals the whole length of 45. Okay, we need to combine our like terms. We have 2x squareds. We have a negative 20x and a negative 7x. That gives us negative 27x equals 45. But because of that x squared, we know we're going to have to do something different other than just solve for x. We're going to probably have to factor. So let's get everything on the same side so that we can factor. So let's move the 45 over. We have 2x squared minus 27x minus 45 equals 0. Okay, let's go over here. I'm going to make an x, and we can say our AC and our B. Our A and our C gives us negative 90. Our B right here gives us negative 27. And so what's a factor pair of negative 90 that's going to add up to negative 27? So we want one negative, one positive. Our bigger number has to be negative. So we can see here negative 30 and positive 3 is going to give us both of those values. So let's expand our equation out and say 2x squared minus 30x plus 3x minus 45 equals 0. So I just took the negative 27 and split it into the two pieces. So let's split this in half and take out our GCF. Our GCF between 2x squared and negative 30x. We can take a 2 out of both those numbers and an x, and we're left with x minus 15. Looking at the other side with 3x and a negative 45, the biggest number we can take out is the 3, and we're left with x minus 15. That's good. We got x minus 15 in both set of parentheses. That's what we always want. And now let's combine our GCFs together. So 2x plus 3 and x minus 15. Okay, that's our equation factored, but we're not done because they do want us to solve and figure out what x is. So I'm going to take both of those and I'm going to set them equal to 0. So we had 2x plus 3, and we can solve that. We move the 3 over, it becomes negative. Divide by 2, x equals negative 3/2. Okay, but we had another set of parentheses, x minus 15, so we have to set that equal to 0. We can move the 15 over, and x equals 15. Now, not both of these solutions are not going to work. We have to check for extraneous solutions. They might work, but we have to always check. So if we were to take that 15 and plug it back in, and my mind always goes to the positive whole number first because that's easier to check. If I were to take that 15 and plug it in, 15 squared minus 20x, and then I do 15 squared minus 7x, that's not going to give me 45. That's way too big. So I know that this guy's out. Our solution is going to be -3/2. So looking at our question, we've set up our equation, we've solved it, we've checked for extraneous solutions. Now we have to take that and plug it in and see actually what is the length of LM and what is the length of MN. So let's go over here and let's plug that in. We have x squared, which one is it? LM equals x squared minus 20x. We're going to take that -3/2 and we're going to substitute it in. So -3/2 squared minus 20x. Whoops, not x. We now know what x is. And if we were to plug all that in, we would cancel out the negative because when we square a negative, it cancels. So we would square that, do the -20 times the -3/2, and that would give us 32.25. Okay, we're going to do the same thing with MN, and that was x squared minus 7x. Again, we're going to substitute -3/2 in, minus 7 times the -3/2, and see all those negatives are canceling out. And if we were to plug all of that in, that would give us 12.75. Now, we've got some different numbers you're not used to, and again, decimals are not bad. You can always have a decimal. You just can't have a negative distance value at the end. You can have an x being negative, but not your final answer. So let's go through here and check. Does 32.25 plus 12.75, the 75, give us 45? Does that work? Plug it in and check. We can see, yes, it does work. And so we know our final answers here for that problem. Okay, let's keep rolling through this. Now we're going to switch over to some angles. We're still talking about that same postulate, part plus part equals whole. But with angles, we have to have what's called adjacent angles. And we talked about that in our vocabulary lesson. Adjacent angles just mean that they share a side. They're not congruent. They can be, but they don't have to be. They just share a side. So let's do a quick sketch just so you can visually see. Let's start with a big angle here. Let's split it somewhere between. We know because an angle is made up of rays, we need all these points to make up our rays. We can see angle 1 here and angle 2. And you can see here is the shared side. Those are adjacent angles. So if we were to take that in terms of our angle addition postulate, think of it like this. Angle 1 is one part. Angle 2 is the other part. We put them together to get that big angle that is made up of angle 1 and angle 2, and that gives us the whole thing. So it's still part plus part equals whole. Okay, and again, there it is to remember. So let's take that and apply it to some sample problems. So we have here angle AOC is 70. We can trace that and say AOC is the whole thing. So we can go over here and say AOC is the whole thing at 70 degrees. They also gave us AOB. Trace your letters if you need to. AOB is right there. That is x plus 10. And then BOC, trace BOC is x. So we can see here our two adjacent angles, AOB and BOC. we have our part, and our whole. So let's set up our equation. First part is x plus 10 plus the second part is x, and that gives us the whole length of, or the whole measure at 70 degrees. So now let's just solve for x. Combine your like terms. We have 2x plus 10 equals 70. Move the 10 over, 2x equals 60. Divide by 2, x equals 30. Okay, so that's what x is. Again, it's not asking for x. It's asking for us to plug those in. So let's take the first one. BOC is x plus 10. So if we take x plus 10 and substitute 30 in there, that gives us 40. And I'm going to draw an arrow here so you remember where we did that work. AOB, I did that backwards. We did AOB. So let's just erase that. I apologize. And let's move that here. Make sure you're reading that carefully, not like what I just did. So now, BOC, we can look at BOC as just x. Well, that's really easy to substitute. X equals 30. And we have that degree. Draw an arrow. And we can say, does 30 plus 40 equal our total of 70? Yes, we know we're correct. Now it says classify angle AOB. So AOB is right here. Classifies what kind of angle it is. Not the name of it. What kind is it? Is it acute? Is it obtuse? Is it right? Is it straight? And we can see here that the measure 40 is less than 90, so it is an acute angle. Okay, last little bit here. We have some adjacent angles. They're sharing some sides. Looking up here at the top, it says ray FG bisects, and remember we learned the word bisect in our vocabulary lesson. Bisect means cut in half. So FG is cutting angle EFH in half. Well, let's label that on our picture here. We can say here is our bisector, okay? We now know that this angle EFG is congruent to this angle here GFH. Those will be the same. So whatever one is, the other one will be also. It also says that IFH is a straight angle. Well, we learned the other day that IFH, or straight angles, equal 180 degrees. Okay, so let's see what information they are giving us. They're telling us in example 6 that EFG, so EFG, one of those congruent angles, is 5x minus 10. Okay, they're also saying that GFH, the other congruent angle, is 3x plus 25. Well, do you notice here that they didn't give us the whole thing of EFH, those two put together? All they're telling us is that they're congruent. So when you just know that two parts are congruent, the way you set that up is part equals part. So we can substitute in and say 5x minus 10 equals 3x plus 25. Okay, let's subtract our 3x over, and so that leaves us with, and I'm going to write it over here, 2x minus 10 equals 25. Add your 25 over, 2x equals 35. Divide by 2, x equals 17.5. That's okay to get a half there. It's nothing wrong with having a decimal. But again, they're not asking for x. They're asking for the measure of IFE. Well, IFE is over here. That wasn't even part of that. But we do know that we can find our parts over here and subtract from 180 because we know together it makes a straight angle. So let's substitute this in and say, okay, which one's easier? Let's deal with the 5. Let's say 5x minus 10. So substitute 17.5 in. And if we plug all that in, that gives us 77.5. But again, that's only one of those parts. So we have to double it to get the whole measure of EFH, which gives us 155 degrees. So that means together, these two are 155. But again, that's not what they're asking for. They're asking for IFE. And so if it makes a straight angle, we would say 180 minus 155 degrees gives us 25 degrees. And that's what they're looking for. Always pay attention to what the question is asking you to find. It may take several steps, but make sure you're looking at what it's asking you to find. Okay, last question here. I'm going to erase my scratch work there, but I will be putting back my givens. I was given at the beginning that that was 180 degrees, and I was given that these two are congruent because FG is a bisector. So now let's label what was given in example 7. GFH, so I can trace here, GFH is 3x plus 20. EFH, be very careful which one it's talking about. Look what it's talking about here, not a congruent part. The whole thing is 4x plus 80. Okay, are those two parts congruent? No. 3x plus 20 is a part, 4x plus 80 is a whole. So I know that I have to use part plus part equals whole. But was I given both parts? Yes and no. It wasn't given in the problem, but I do know that these two parts right here are the same. So if one of them is 3x plus 20, the other one is 3x plus 20. So we can use that for both parts. So let's substitute that in. 3x plus 20 plus 3x plus 20 equals the whole thing of 4x plus 80. So when you have two congruent parts and they give you the whole, plug those parts in for both those p's. Now let's combine our like terms. We have 6x plus 40 equals 4x plus 80. Let's subtract our 4x over, and that gives us 2x plus 40 equals 80. Let's subtract the 40 over. I'm going to move over here and say 2x equals 40. Divide by 2x equals 20. What's the question asking to find? Not x, but we need it. It's asking for the measure of EFH. Well, I can see here in the question, EFH was the whole thing, 4x plus 80. So let's take 20 and substitute it in. The measure of angle EFH equals 4x plus 80. Let's substitute the 20 in. 4 times 20 is 80. 80 plus 80 is 160 degrees. And that's your final answer. So one thing I want you to think about as you're working through this, part plus part equals whole. If they don't give you a picture, draw a picture. Label your picture. It'll make a world of a difference, and it'll make this so much